Okay, students, so I think that we are live now, and yes, so I'm starting the class here. Okay. Okay. Welcome everyone to today's class. So good afternoon, everyone. I hope I'm audible to all of you. I think I'm audible to all of you, okay? So I'll be launching a poll if it's visible on your screen. So please participate in that. Okay? Got it? But still we'll wait for like 2 more minutes so that all other students may join and then only we can start the class. Okay? So let us wait for 2 more minutes. If you're having any doubt related to previous day's class, okay, so you can text me in the chat box. Yesterday's class. So you can please text me in the chat box. Okay? Okay, let me check on the YouTube what is happening there. So I'm audible there. Okay. So last 1 more minute is remaining. Okay, then we'll start our class. Last 1 more minute is remaining and then we'll start our class. If you are feeling any doubt, please text me in the chat box so we can clear it. Okay, that's fine. Okay, so it's 3 p.m. now and we are going to start the class. So welcome everyone. What we have studied in the previous class. Okay, here I'm taking this yellow color. So this was the topic that is ray optics. Okay, see if you're feeling any audibility issues, please text in the chat box. That's fine. Okay, so this was a ray optics topic we have already started. Okay, uske baad this was the next slide. Yesterday I talked about revision and contents. Okay, revision and content. Okay, so one more student have joined. The name is okay. Kambe have joined and admin have also joined. So welcome to today's class. I'm not waiting for more like for other students. Okay, so let us start it. Recall question. Okay, first we'll be solving a recall question. Also, we did the same thing in the yesterday's class. Okay, so I will show you that's recall question again. Don't worry. Okay. See, we haven't completed this topic. That is the second number topic. That is combination of mirrors. ये topic नहीं किया था ना? Okay, so we'll see the theory of this topic today. Okay, and we'll solve the numericals related to this topic. That's fine. Okay. Refraction. After this, in the previous yesterday's class, before ending the class, what we did, we have studied somewhat about refraction. We have seen an animation video. हमने क्या देखा? We have just seen an animation video. Okay, and I haven't explained you a lot about this. In the theoretical manner. So today we'll be seeing that. Got it? Okay. Any doubts? Yes or no? Please text in the chat box. Any doubt? Okay, I haven't removed this pic. That was a National Girls Child Day. Okay, I'm removing. Just hold on. So here we go. Choose virtual background. Okay, what are you saying? Sir, remove the video. I've removed this. Now it's working. Fine. Okay, I'm stopping the video. So these three things which we are like recall question we have already did in the previous class. Combination of mirror theory we'll see today. And after this refraction theory. Okay? After this, if we are left with some time, what are we going to do? What will we do after this? After this, we'll see the theory of apparent depth and normal shift. We'll see the theory of apparent depth and normal shift. After this, refraction through glass slab. Okay, suppose there is a glass slab and it's like this. Okay, and some ray passes through it. So we'll see that when the ray passes, okay, let me on the video. So we'll see that when the ray passes through a glass slab, what happens? It gets literally shifted. Okay, so there is a particular d perpendicular distance between the initial ray and the emergent ray that we'll see. Got it? Okay, so after this we'll see a topic that is lateral shift, which I have already talked about, the second last. Okay, you'll see it is having a particular formula which contains thickness also, thickness of a slab also. Got it? Yes. So these are all the contents of today's class. If you are clear with all of this, so please text yes, otherwise no issues. Okay, you can text no also. I'll explain it again. Okay? Yes. Recall question, combination of mirrors, refraction. After this, apparent depth and normal shift. After that, refraction through glass slab. After this, lateral shift. Okay. So this was a previous question. I mean, this I took as a recall question in the previous class. I hope you be all of you are alert about this, है ना? This I took as a recall question in the previous class. Okay, so I'm audible now. I hope I'm audible. नहीं मिला. Yes. So students, I hope that I'm audible to all of you now. Okay. So this is a previous recall question. Okay, I took this question and we solved this thing. So the object distance here was given as -5 centimeters. Okay. And radius of curvature here is given as 20 centimeters. But if we see the focus, it will be equals to F is equals to R by 2. Okay, this is equals to 10 centimeter. And you, all of you students must know this thing because it's very, very important. Okay. It's one of the important thing, like most important thing here. Okay. That focus here is 10 centimeter and the mirror is what kind of mirror? Sir, a mirror, so it's like a concave mirror. Hai na? We can see this. So that's why what I did, concave mirror mein focus kaisa hota hai? Is it positive or negative? You have seen this thing, it is negative. Okay. And remember this, for convex mirror, you will take focus to be positive. So these are two things here. Okay. After this, we have used the formula which connects the image distance, object distance, and focus. Through these three things, we got the real answer. That is image. We have seen it was real, virtual, and all these things. Okay. After this, we have seen something known as magnifications. That is height of the image upon height of the object is equals to minus v by u. Okay. Height of the image, height of the object minus v by u. This is like this. This is height of the image. This is height of the object. V is what? Image distance. U is what? U is what? Object distance. Okay. This formula I told you specially, like peculiarly, I told this to you people specifically that remember this formula always. Okay. Keep remember this formula throughout the class. Got it, students? Very good. Intelligent. See, after this, we have used this trick here. This is a tricky formula which combines the height of the image, height of the object minus v by u. Okay. So we have used this formula here. Okay. So your height of the object is given in front of you, it's 4 centimeter. Height of the image is something like this. And this is v is the image distance. Okay. And u here is what? U here is object distance. So through this, you'll get all the values. Okay. And we have seen this thing here that it was convex mirror. So for convex mirror, focus is what? It is positive. Got it? So this is the object distance. Image you have to find. You have all other things. We have solved this question also. After this, we have arrived at the velocity. Okay. So this question ko solve karne ke liye what we did actually, anyone of you? For solving this question, what we actually did? Koi bata sakta hai? Anyone of you here in the class? Okay. So few more students have joined. JNV Vishakhapatnam students have joined. Excellent. So I'm seeing these students are the new one. Okay, that's good. It shows your sincerity towards the class. Very good. Excellent. Okay. Okay, you want me to close this? Or? See, this question in the previous class, we have solved it. Let me tell you what the thing we did here. We derived a formula. Formula was like this. Velocity of image with respect to the mirror is equals to what? Minus v square by u square. Velocity of object with respect to mirror. This was the thing. Okay. And we know here that velocity of image minus velocity of mirror minus v square by u square, velocity of object minus velocity of mirror. This is the formula in front of you. Okay? Velocity of image minus velocity of mirror minus v square by u square, velocity of object minus velocity of mirror. This was the formula. We have derived this formula. Okay, and then we have used this formula in this question and we got the answer. I still today, I mean, till today, I remember this, the answer of this, which we have solved in the previous class. What was the answer? Answer was this, minus 7 by 4 centimeter per second. This was the answer, that is minus 7 by 4 centimeter per second. Okay. Image speed. Minus 7 by 4 centimeter per second. Okay. After this, students, we were on this picture. Okay. We were on this question, if you see. So, is question mein kya tha? What was the important thing in this question? Any one of you? What was the thing in this question? Okay. So, this question ki speciality is this. This question was having the object O, which, and the coordinates of this object were given, minus 40 and 1. इस object में, इस objects के coordinates दे रखे थे students, that is x, y. So we did what we have written like this. We have compared this with this, x and y. Where x we got as minus 40. Y we got as 1. Okay. So through this, now we need what? We need the next thing, that is, they're asking to find the position of the image. When they say like this, find the position of image. When they say like this, position of image, it means position of the image का मतलब क्या है? Coordinates of the position of the image. Coordinates of the position of the image. Okay, coordinates of the position of the image. Okay, vxy. So we'll find it here. So x, y is this. Minus 41 is what? Coordinates of the object. Okay, so we treated like this. Ki x kya hai? X is resembling the object distance and magnitude. Okay, right, like this. Object matlab minus 40. Okay, y is resembling the height of the object here. Okay, so it is 1 centimeter positive. So if they're asking you the position xy coordinate, it means like this. They're asking you the object distance of the image and they're asking you the height of the image. They're asking you the object distance of the image and they're asking you the height of the image. Okay, u of image or height of the image. Image distance they're asking. Okay, so let me write it more properly here. It is basically v, not u. Image, see, u and v are basically the symbols. They are distances. U is, why they have differentiated u with v? Because see, what they are doing is this. U और v को differentiate क्यों किया? Because u मतलब object, v मतलब image. But है तो distances ही ना. These are distances only. Got it? So you can see here with your eyes. Yeah, Nilima have also joined. Like JNV Chitra Durga students have also joined. So okay, that's fine. So that's good. Okay, so you have joined. Please be focused. Okay, so till now I'm just revising the things. Okay, all of these students who have joined now, I'm just revising the things of the previous class. I will start the session now, brand new today. Okay, let's wait 5 more minutes. Okay, so be focused on the PPTs, not here. Okay, so through this we have solved the question by using that same formula. See, इसमें the use is only this much xy coordinate. So हमने formula use किया था 1 by v plus 1 by u equals to 1 by f. Through this we got the answer. Got it? Yeah. So now this is the brand new topic, students. Listen here carefully. See here carefully. This topic, that is the combination of of mirrors. First of all, text me. कोई technical issues तो नहीं है? Text me students से. Technical issue तो नहीं है? Anyone? JNV Visakhapatnam, JNV Chitradurga admin or Nilima Kembe. Please text me here. Is there any technical issue? Audibility is clear. These two things are must condition here. PPT and audio. I've already asked you from the beginning. Because this is a new topic, I have to ask again. Otherwise, I don't want any issues. Because this is very interesting topic. Okay. Combination of mirrors. Okay. Thank you so much, Nilima. You have answered it. That's great. Okay. So now be focused on the PPTs. Okay, cool. See here carefully, students, what is happening. So in front of you, this is a plane mirror. This is a plane mirror. This is a concave mirror. Okay. Radius of curvature here is given as 20 centimeter. इसका क्या मतलब है? इसका मतलब simple है. Center of curvature is 20 centimeter. Object is at 15 centimeter from this concave mirror. Okay. And they're asking you, what is the question? Distance between the concave mirror and the mirror is this. See the video. Distance between the concave mirror and the plane mirror is 40 centimeters. Okay. And they're asking you here, you have to find the position of the final image after 3 successive reflections. Okay. First reflection you have to take from M1. So at first you are having this mirror that is concave mirror. This is what mirror? This is concave mirror. This is M1. Okay. This is concave mirror. It is M1. So they're telling us in the question, they're giving the hint to us that we have to take first reflection from M1 here. Okay. M1 matlab concave mirror. So here if we see the principal axis, this is the principal axis. And you can see properly that the principal axis is at, object on the principal axis is at 15 centimeters. Okay. Object on the principal axis is at 15 centimeters. Okay. So now what's the thing? You have to find the image distance. Okay. So how are we finding the image distance? Simple. You have to use a formula that is 1 by V plus 1 by U equals to 1 by F. Got it? U kitna hai yahan pe? U, if you see, all is this point. U is what? U is minus 15 centimeters. Take, put this value in this. Okay. Now put the focus. What is the focus? We know for the radius of curvature for concave mirror is what? 20 centimeters. This is the radius of curvature. Focus kitna hota hai? Focus is defined as radius of curvature ka half. Since this mirror is concave mirror, so we'll say we'll use focus value to be what? We'll use the focus value to be negative. Okay. We'll use the focus value to be negative. So we'll put here F is equals to 20 by 2. F is equals to 10. That is minus 10 here. Okay. So I think one student is having the doubt. So let me ask, what's the doubt? Okay. So you are telling the answer. Okay. Very good. So you're saying that focus is minus 10 here. That's fine. Okay. So now put these values. 1 by V plus 1 by U. U is what? Minus 1 by 15. Focus is what? We got the focus as minus 10. Okay. Isme say now you have to find this V, that is the image distance. Okay. So let us find out this distance, then we'll see what happens next. Okay. So this is the value 1 by V minus 1 by 15 equals to minus 1 by 10. 1 by 15 minus 1 by 10. If you solve this, what will come? So let us take a yellow color kind of thing here. 1 by 15 minus 1 by 10. How much is this, students? 15 or 10? I'll find. So it's a 15, 5 to the 10, 3 to the 3. So this is what? This will give you 30 thing. Okay. 30 is here. 15, 2 is 30 minus 10, 3 is this. So this will be minus 1 by 30. This is V. So in front of you, genuinely, I've solved this. Okay. You can say now, so no issues here. So it's V will be minus 30. That is minus 30 centimeters. So after solving this question, students will get this thing. What you will get? What? So this is key. If the object is at distance 15 centimeters from this concave mirror where the pole is the center point, image will be where? Image will be double of this. That is, suppose this point is what? 30 centimeters. Okay, I'm writing here, this is 30 centimeters. So this will be the image point. Got it? So now listen one thing carefully. See, so I want the video, you can see I'm demonstrating you something here. See, वो object था, what was the object? It was concave mirror. Okay, concave mirror से principal axis पे object was at 15 centimeters. So they have specifically told you in this question, first reflection you have to take from concave mirror, then one more reflection from the plane mirror, then one more reflection from the alternative, the second mirror, that is again concave. So we'll take the three reflections starting from the concave. Okay, but now you got here the distance of the first image, which is after the reflection from M1 mirror is what? You can see it in the sheet that it is 30. So I'm drawing the image with red color, because red color, like, it appears kind of from a distance too. So this is 30 centimeters. I think it's visible more better than this blue color. This is the image 1, Mr. 1. This is what? Image 1. Okay. Now, since you got the image 1, first reflection completed. So first reflections are completed. Now we are having remaining 2 more lifelines. Okay. So let me not write like this. Okay, it will be fine. No issues. So first reflection is completed. Second is remaining. Third is remaining. We are having 2 more lifelines here. What we need to do? So now we'll see the second reflection, but from where? From the plane mirror. So first was for C. Let us give the batches here. I'm giving here what? Batches. Okay. No, I mean say batches it is. So this is what? One is C. Second is what? Second is plane mirror. Third is again concave. Okay. Second is plane mirror. So we'll see here that this image, which is a distance of 10 centimeters from plane mirror, it will be having its own image. See, this image which is formed from concave mirror will be acting as a virtual or real. Let me ask from you. What do you say? Please text in the chat box. Concave mirror से object की image बनेगी. That image will again act as what kind of object? It is as a virtual object or a real object? Okay, don't worry about that. See, if you see it carefully, this image is real image. Image is real. Okay, so rays will be coming from this also. So it will be acting as an object for this. Okay, so treat it as an object. This is at 10 centimeter. Image will be forming here at 10 centimeter because we know the concept of plane mirror. So suppose you are having a plane mirror like this. Okay, let me draw it in a more proper manner. Okay, 2 students have texted me something. Let me see what they say. Yes. Okay, no. So suppose we are having a plane mirror like this. This is plane mirror. Image, real image, the image 1 due to concave mirror, it was actually at a distance of 10 centimeters. Okay, it is at a distance of 10 centimeters. So the image will form at 10 centimeter here. Okay, you can see it carefully. Image will be at, the image of concave mirror will be acting as an object for this plane mirror. So this object, if it's in front of this plane mirror at 10 centimeter, image will be at 10 centimeter only. Got it? So we'll get the image here. That is the second image. Okay. Now this second image, which we know actually is a virtual image, 100%. This is what kind of image? It is a virtual image. Okay. This virtual image, which is I2, will be acting as a virtual object. It seems to our eyes that it will act like what? A virtual object. I2 image will act as a virtual object for spherical concave mirror. Okay. So let me draw it there on the screen so you can see with your eyes here. I think it's visible to you properly. Okay. Okay, I think I have to draw the structure again. So let me show you in a new screen. So the picture was like this. This was concave mirror. This is a kind of concave mirror. Concave, 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 concave. This is principal axis. Okay. This is concave mirror. This is what? Principal axis like this. And this is what? Plane mirror. Okay. Concave mirror, plane mirror. Distance between both of these is 40 centimeters. We got the first image at 30 centimeters. Okay. And we got the second image as this, that is 10 centimeters. Okay. And I have told you that this second image, which is a virtual image, this second image, which is actually a virtual image, is acting as a virtual object for concave mirror again. Because see, in the question it was said you have to take 3 successive reflections. Okay? You have to 3 continuous reflections you have to take. Three number. Okay. First is this, second is this. Now it's the time for the third one. This is the time for the third one. Okay. So this virtual image I2 will be acting as a virtual object. Total distance iska kitna hai? If you measure the distance, you will get this thing. If you measure the distance, this will get as this thing, that is 40 plus 50. This is the distance of this I2 image from concave mirror. This is the distance of this I2 image from this concave mirror. Okay, that is 50. So now you will treat this virtual image in this plane mirror as a virtual object and put the distance to be u equals to minus 50. Simple, very easy, one of the easiest thing. Let us switch back and see the values. Am I right? Yes, 40, 10, 50. Good. So this is u minus 50. Now we need the last reflection, that is what v. Okay. So if you'll see this last reflection, I can show you on the screen that the last reflection is what? 1 by v plus 1 by u equals to 1 by f. Okay. Focus here, if you'll see, focus is, what is that? The focus doesn't change. What's the reason? Okay, let me ask you this question. Why is the focus is not changing in this concave mirror? What's the reason behind this? The reason is this, because spherical mirrors, we know there are two types, convex and convex. Oh, sorry, concave and convex. Concave will be curved along one center. Convex will be on the other side of the center. Okay, center will not change since they are the part of the same spherical mirrors, so it will not change. Due to which we'll say what? We'll say like this, that the radius of curvature doesn't changes. Due to this, focus will not change, because we know this thing. Focus is radius of curvature ka half. Okay. Finish. Now, what to do next? See, u is minus 50. U is minus 50 centimeters. Yes. Any doubt? Please mute yourself. Focus we are having minus 10. Focus minus 10 hai. U minus 50 hai. Please mute yourself, okay? Otherwise I have to mute you. Who is this? JNV Visakhapatnam students, please. Okay, I'm muting you. Mute yourself. Good. Yes. So we are having this, that is 1 by v plus 1 by u equals to 1 by f. Okay. Put the values. U kya put karenge? U you will put here as minus 50. F you will put as minus 10. Okay. We'll get the final answer. So I3 value will be this. Minus 1 by 50 minus 1 by 10. 1 by v equals to 1 by 50 minus 1 by 10. What is this? What the answer is? Take 1 by 10 common. 1 by 5 minus 1 by 10. So this will give you what? Minus 4 by 50. Okay? This will be equals to 25 by 2. Finally, students, you will get this answer. That is, you want on the next slide? Okay. So finally, you will get this answer. That is 25 by 2. 25 by 2 is how much, students? What's the value of 25 by 2? Okay, it is 12 point. Yes, any one of you? Yes. So one of the students have texted me, it is 12.5. 12.5 is the answer. But what will be the sign? It is positive or negative? What do you say? The sign is positive or negative? Text me fast in the chat box. The sign is positive or negative? What is it? Yes. So Udupi students say that it's negative. Bina says it's negative. Nilima says it's negative. Excellent. Okay, very good. So this shows that you are really concerned about the class. You are focused here. So V is actually minus 25 by 2. That is something like this. That is 12.5. Okay. So if I draw the complete picture again, that is what was given in the question. Okay, sir, you have to take first reflection from concave mirror. After that, you have to take the second reflection from the plane mirror. After that, again, you have to take the first reflection from, the third reflection again from the concave mirror. This will give you the final result, that is I3. So let us draw the images and check it out. Okay, what was the result? So it's very interesting result, by the way. Okay, it's very wonderful result here. So this is concave mirror. This is principal axis, concave mirror, principal axis. This is pole here. Okay, this is plane mirror here. Okay, plane mirror that we use in the houses. First image is at this point. Which colors you want me to use? Okay, I'm using the colors of my choice. Blue. Ivan. Ivan is how much? Well, where's the images? Anyone? Kya answer tha? It is 30 centimeters from this. Okay? From the pole. We know the distance between the concave mirror and this plane mirror is 40 centimeters. Okay. Second image is where? Yes, second image is where? Second image was at 10 centimeters there. Second image I2. Second image I2 is at 10 centimeters. Okay. And third image is where? Where will be the third image? Third image again is at V equals to minus 12.5. It means taking pole as a reference. This is the pole, which is a reference here. You have to go 12.5 in the negative side. Okay. So go here like this. So we'll say this is the I3 picture, which is the last image formed. Okay. Yes. So JNV UDP students, you have given the excellent answer. 12.5 from the concave mirror is the right answer. So ultimately, if we see the ray diagrams, it will be very complex. Sorry, it will be very complex kind of. Ray diagrams will look very complex. Got it? This is the final answer. Just let us switch back to the questions again. So combination of mirrors. Okay, it's not an easy. I'll say that if you understand it, it's easy. But for a beginning, for like a beginner, so please mute yourself. Okay. Who is please mute yourself. Okay. See, if next time if I've seen you like unmuted, it's not fine. Okay. We have told you officially. I have closed the host. And in the host settings, I've put this, all of you students to be muted. Then why you're doing this? Okay, leave. So now I'm closing my video here. Now let us see the second question. Okay. So first question in the series of this combination of mirror is completed. Now we'll see the second question here. So this is the question, second one. So you're having now two mirrors here, okay? Concave mirrors again. I'm using the black color. Concave mirror one. Concave. Is it concave or convex? Anyone? Are these two mirrors both concave or both convex? Or one concave, other convex? What do you say? Anyone of you? Okay. This, yeah, very good. So one student have texted me, Nilima says concave. Both are concave. I don't think so. So this mirror is concave and this mirror behaves like, yes. ODP student says that concave and convex. Very good. One is concave, which is the left-hand side mirror, and right-hand side mirror is convex. Yes. Yes. So I'll be solving this question also. Then we will fast switch towards the refraction. This question will solve karenge, then we'll switch fast back to refraction. Okay. Otherwise, sub sara time like it will go in this only. Please focus on the slides. I'm taking this white color. See, the question says like this. You have to solve this question in the two continuous reflections. Solve this question in the two continuous reflections, one by one, back to back. Okay. Taking the first reflection from the mirror one, that is convex mirror. This mirror is what? It's convex mirror. Taking the first reflection from this convex mirror. Okay. So see it carefully. Convex mirror object is at 10 centimeter. If we go from the pole towards the object, we're going negative. I'll say for this mirror, U is again minus 10. Since it's in convex mirror, we'll say focus for this mirror is equals to what? It is positive plus 10 centimeter. Okay. Now, first of all, we'll take first reflection. So we are having two lifelines again here. Okay. One lifeline, two lifeline. One for one reflection, second for the other reflection. So we'll do here like this. 1 by V plus 1 by U equals to 1 by F. ठीक? Got it? Put here U to be minus 10. Put here focus to be plus 10. You will get the V. Got it? 1 by V. U is minus 10. Focus is plus 10 because it's a convex mirror. Through this, you can see yourself that the answer is twice of 1 by 10. That is V equals to 5 centimeter. So from this, you get the answer that V equals to 5 centimeter. What does it mean? V equals to 5 centimeter. What does it mean, students? I'm asking from you. Iska matlab, from the pole, we have to move in such direction with the magnitude that is distance linear, that the direction is positive. That is this direction. So I will say the image is formed, say, okay, let me remove these things. Okay. So the image is formed here. That is V is equals to 5 centimeters. Okay. Image is formed here. That is V equals to 5 centimeters. Now this is basically a virtual image. So this virtual image, which is I1, will be acting as a virtual object for the concave mirror now. Okay. So now we'll take this complete linear distance that is starting from, let's take some different colors. So this complete distance, that is 45 plus 10 is 55 plus 5 is 60 centimeters complete distance. Okay. So now the questions becomes like this. Now the question is like this, that you are having a concave mirror. Okay. Object is at 60 centimeters completely. Okay. And this concave mirror is having the focus as 20 centimeters. Remember one point, concave mirror ke liye focus is always what? Positive or negative? For concave mirror, the focus is what? Positive or negative? If this is pole, okay, Bina says it's negative. Very good, Bina. Excellent. Okay. So this, I mean, this, the students who are texting or replying in the chat box, they're making the class offline. Okay. I mean, they're really interested. Otherwise, online class, if you're not responding, students are not responding. It's like teaching in front of the empty class. What's the use? And I mean, not for the teacher also. I mean, nobody's gaining the knowledge. But that's good. You're texting here. Excellent. Okay. So now we are having the distance 60 centimeter for the object. Okay. Focus is what? 20 centimeter. Use the values, you'll get the answer. We know this thing. Now we need the final image, that is second, because in this question it was strictly told take only two reflections. 1 by V, 1 by U, 1 by F. V kitna hai? I ko pata nahi. U kitna hai? U is, students, in front of you. It is minus 60 centimeters. Focus kitna again? Minus 1 by 20. V you will get us like this. Okay, so when you will solve this thing, okay, the answer which you will get is this. V equals to minus 30 centimeter. And this is the final answer. So I2 image is this due to concave mirror. Okay, and this is the final answer. So we'll say like this. What they were demanding on this slide, they were asking find out the position of the final image formed by two reflections. So we get the final image as 30 centimeters, that is minus, so it will be somewhat here. This is the answer, final answer. So is this question clear, students? First reflection hua, image bana yahan I1. Now this image is acting as an object for this concave mirror, that is the second mirror for the second reflection. Then the image is formed at I2, 30 centimeters. Fine. Anybody is having any doubt in this? Yes or no? Anybody is feeling any doubt in this? See, first reflection we took from the right hand side, convex. Second reflection we took from the left hand side, concave. Got doubts? Anyone? No doubts. Excellent, students. Very good. Very good. Okay, so it shows that, I mean, you are getting the things, okay, smoothly. So now we'll be seeing a refraction here. Okay. So now I'll be seeing the reflection here. Okay, just hold on. Okay, so see this animation, it's available on your screens. Okay. So students, I'll be launching this video again. Okay. So see it again and observe again what is refraction, because I think that this is an interesting, cool animation. Okay, that's fine. So I'm launching it again. Okay, then we'll see the theory part again. That's fine. Okay. So if you're feeling any doubts, please text in the chat box. Okay. Okay, students. So now we'll be seeing the theory part. Okay. So we have completed the revision. No issues. Now pace of the class will be fine. Okay. Got it? Yes. Any one of you? So I hope you enjoyed the animation. I hope you enjoyed the animation. That's cool. Now let us go slow and slow because now it's a new fresh topic, that is refraction. We'll see it in a theoretical manner. Okay? Now we're going to see it in a theoretical manner. Okay. See, what is refraction of light? Let us understand this thing. What is refraction of light? See, I think I'm audible. Okay, yeah. In that video, the audio was not there. Okay, you want to see the audio again? Okay, I'm launching the audio again. Just wait. Okay. In that video, that audio was not there. Let me share it again and launch the audio. So share this and launch the audio. Okay. I'm sharing it again. Okay. So see.
Refraction of light.
Huh?
Now the audio is audible to you. Okay.
Why does a pencil look bent in water? Wow, that was a very cool magic trick. Now check this out.
Oh.
Hey, stop crying. Your magic wand is not bent or broken. Look, it is safe. But do you know why your magic wand appeared bent in water?
Oh.
It is because of refraction of light. Refraction of light is the change in direction of light when it passes from one medium to another obliquely. So, what do you think are the two media here? You don't know? No worries. I will tell you. They are air and water.
Oh.
When the light rays coming from the tip of the magic wand pass from water to air, they change their direction. That is, they get refracted. When these refracted rays reach our eyes trace them backward as straight lines. Due to this, the rays appear to come from a point slightly above the original position. Hence, the magic wand appears to be bent in water.
Oh.
Similarly, like the magic wand, a pencil appears to be bent in water.
Okay, students. So I hope that you got the idea. Okay. I'm audible? Yes. So now we'll be seeing the theory here. So just hold on. Let me close this thing. Yes. So now let us talk about a little bit about the theory part. Okay. This is what refraction of light. You have seen the animation. I hope you have observed the points where what is this concept, which explains you the concept of refraction. Okay. So what is this reflection of light? Deviation or bending of light rays from their original path while passing from one medium to another medium is called reflection. So how will we explain this? Okay. Suppose you are having a air or vacuum here. A medium has like air or vacuum. And suppose the light passes with this speed, that is c. We know this thing, that the speed of light is how much? It is c. Suppose we change the medium. Suppose now I take a water like this. Suppose I am having a tub kind of thing. I am going to put here a water. Okay, water. So okay, so this is what? Water everywhere. Now suppose via some source S, I am passing this light here like this. So can anyone comment? Okay, let me ask you a question. Okay, when the light is passing from this water slab, is the speed of the light this same, that is c, or it's less or greater? What do you say? Can anyone comment? So the speed of light in water is cw, in air it's subscript ca. So what you will comment on this, that is cw greater than ca or ca is greater than cw? Okay, let me write the third option also, that is ca equals to cw. Anyone? Okay, so one of the student have texted it is lesser. Okay, so let us see now. Okay, is it less or this thing is greater? So I'll say like this, that if the light passes from air or vacuum, the speed of light is c here. And if the light is passing from this water thing, okay, the speed of the light reduces to c by eta. Or you will write here like this, c by mu. Mu is the refractive index of water. And what is it? Anyone like anyone of you knows the value? Do you know the value? It is basically 1.33 for water, and for glass it is 1.55. Okay. So now you can see with this formula, you can analyze the formula and say like this, that the speed of the light in the medium reduces by the factor of this, that is eta or mu, which is the refractive index of this medium. Okay. So by understanding this, or by like having the interpretation of this numerical formula, you can conclude this at the last like this, that suppose more refractive index implies less speed of light in that medium, because refractive index is inversely proportional to the speed of the light. So more refractive index, less speed of light, and less refractive index, okay, let me use the different color, less refractive index, more speed of light. Okay. So due to which it's known as denser or rarer. Denser matlab kya? Okay, this point also must be clear in your mind, that denser ka matlab hota hai, denser medium is that medium which is having the more refractive index. Okay. And rarer medium is that medium which is having less refractive index. Okay, more refractive index, less refractive index. So, and this is a numerical formula for you. Okay. So this is a numerical question based on that formula. Okay, before solving this, we'll see some laws of refractions. Okay, just hold on. Okay, let me explain you those laws on the slides only. So this is a question in front of you. I hope you all are able to see this question on your slides. So I'll be solving this question and then we'll end the class. That's fine. Great. Okay. So see this, what is happening? This is a boundary which is separating two mediums. First medium is water, mu is equals to 4/3. Second medium is air, mu equals to 1. Okay. And this angle is given to you, that is angle of incidence here is sine inverse 3/5. And the next angle is theta A, which is in the air. So remember 2 points. Okay. Although we are having a good amount of theory before this, but I'll try to cover this via this numerical. I will try to cover the theory via this numerical. Okay. So it's like this, ki suppose the light ray passes from, if the light ray passes from, say, denser medium, here it is the medium which is having the more refractive index. If the light ray passes from denser medium to what medium? Denser medium to rarer medium, that is air. Okay, it will bend away from the normal. It will bend away from normal. This is the first point. Mark it as a star point. Okay, next star point is this, vice versa. That is, if the light ray passes from the rarer medium, so this is the observation or the conclusion of the process of refraction. Okay, if the light ray passes from rarer medium to denser medium, rarer medium to denser medium, what's gonna happen? The light ray will bend towards the normal. Okay, so you can see this thing, just apply these 2 star points here. You can see this, that the light ray is starting its journey or incidence angle is in which medium? It is in water, denser, and going towards the air. So it's fluctuated by theta a, that is theta a here is greater than theta I. Okay, got it? Now, sir, what is the formula for solving this question? I mean, what's the requirement what's the need of this mu, and what are all these things? And what is asked in the question? In question, they're asking us theta A, that is the angle of refraction. So, students, no need of the derivation. Just remember this formula, that if you are given two mediums, which is separated by this white line, boundary line, and they're having their individual refractive indexes, that is N1 and N2. And suppose the ray enters like this, I don't know whether N1 is greater than N2 or N2 is greater than N1. This formula which I'll be writing, you have to remember this always, and it is valid for all the conditions. Okay. So this is this R. Okay. So remember the formula that you will write this N1 same. See, if this angle is R in the medium N1, write N1 multiply the sine of this angle equals to, if this angle is in this medium, multiply this angle with N2, that is the refractive index of that medium, into sine of that angle. This is the trick. Okay, sorry, this is I angle. Okay, this is a trick. Got it? Now let us apply this trick on this question. I'll be solving this in a gap little bit here. Yes. So if you see this mu is 1 into theta a ka sine, because it is in this medium only, that is 1 sine theta a. This is 4/3. This is sine theta I. But you are already given theta I equals to sine inverse 3/5. Okay. See, you are given theta I equals to sine inverse 3/5. So I will write sine theta I is equals to 3/5. Okay. So sine theta I. Now compare both of these things. So compare up one, that is this equals to this, and solve it. Okay. So you'll get like this, that is क्या मिलेगा 1 into sin theta a equals to 4/3 sin theta I. And you can see this sin theta I is 3/5 given in the question. Put these values here. From this you will get theta a is equals to sine inverse. From this you will get theta a equals to sine inverse 4/5. Theta a equals to sine inverse 4/5. Got it? This is the answer. And with this, we'll end our class, students, now. Okay? Okay, text me one more time. Is this question clear to you? Yes or no? Then only I can leave the class. Okay? Otherwise, anyone of you? So we started with a very quick revision. Then the combination of mirror topic was remaining, that we have done like in a very fast, like jet mode. Okay? Now we were slow in this topic, reflection. Okay? Got it? So as the new topic starts, speed will be less. I mean, speed will be slow. Okay. So it's up to you. If you're saying like this, sir, keep on like move very fast throughout this topic syllabus. I'll be working according to you people as per your convenience. Okay. If you want the fast speed, I'll be fast, like a revision mode, even in the new topics.